Hey there, so this is just a quick run through of question 1 in case you were stuck on it. This is a Venn diagrams question. Let me just make sure you can see the question there. So we've got 3 sets, A, B and C. We've got some of the probabilities and some of them are missing. We're going to find P, Q and R. Part 1 of this question just says write down the 2 events that are mutually exclusive, and of course mutually exclusive just means they can't happen at the same time. So things like, owning a car and not owning a car. There's a grey area in the middle. You are the owner or you're not. So in this case, it just means the 2 that aren't overlapping. We can't be in circle A and in circle C at the same time. So A and C are mutually exclusive. This is part A. Okay, if we are to prove that, let's say we didn't have a Venn diagram, we just had some numbers, we would have to show that there's no crossover, and that would mean that that is an empty set. So the crossover is described as A intersection C, hopefully you looked at that, that has no one in it, which we can write shorthand, is always a shorthand in maths, we can write it like that in set notation. We can also write it, and this is maybe more useful when we're dealing with probabilities, that the probability of someone being in the intersection is 0. So there is no chance of, say we were to take 100 people, there's no chance of anyone saying, yes, I have a car, and yet I don't have a car. Maybe you can think of more concrete examples like that. So this is no probability in the gap here. So that's part A. Part B, we've got 3 unknowns. And even before we jump into a question with the facts, because we're given independence for A and B, we're given probability of C is 0.3, we've actually got 3 unknowns. And in order to find 3 unknowns, you get plenty of marks for doing that, you're going to need either 3 equations or 3 pieces of information. So this comes up in all across the scope at A level. It's no longer going to be obvious that it's a simultaneous equation or we need to eliminate a variable. We see it a lot in mechanics, 2 unknowns, 2 equations, and here we've got the same thing. We've got 3 unknowns and 3 equations. So let's see what those 3 equations are for part B. So we've got there 3 pieces of information. The first piece of information is that A and B are independent. And I'm going to write this as a kind of, in a proof kind of way. So sometimes we're asked to show things in these questions, so we need to show our steps one by one. So A and B are independent. So really think about, you're explaining it to whoever's marking it. Try and really nail it as, so this must be true. So A and B are independent. Now, we've been given a little formula that helps with that. And if you remember back to GCSE probability, if we are on a tree diagram, event 1 happening and then event 2 happening, we can just multiply along. So the chances of them both happening in any order is just the chance of one of them happening multiplied by the chance of the other one happening. So an example of that would be if I tossed a coin and rolled a dice. They are independent events. The outcome of one shouldn't affect the outcome of the other. So we've got 2 events and we can just multiply their probabilities to find the chance of a particular result. So this might be chance of a head coming up and a 6 coming up. So probability of heads and 6, I'll put the intersection sign in, that sort of means and, doesn't it? Would be a half times, half for that one, times a 6 for that one. So it's you can just go back to a simple example. I'm going to get rid of that because we've got our own probabilities here. So for this question, the intersection of A and B, we just read it off the diagram, we've already got that. We've got 0.15 on that side, and on the other side, probability of A times probability of B. Make room for that. So 0.15 equals, so this is a little bit trickier. Probability of A is all of this lot, so it is both of these added together. So if B was something completely different, so that's the probability of A in there. If B was something completely different, like owning a cat, then we've got to include both of these sections. This is people who have a cat and a car, and this is people who just have a car and a cat. And we're going to multiply that probability by the probability of being in B. And the probability of being in this set is the combination of all three of these probabilities. So again, we can just add those. 0.15 plus 0.1 plus P. So I'm really showing this step by step. You can, if you can do it accurately, you can add these together. This is 0.4 and this is 0.25 plus P. So we can leave that bracket in. And then we can kind of massage that. Do use your calculator. There's no need to work yourself that hard unless you want to practice. We're going to divide by 0.4, so 0.25 plus P is going to be 0.15 over 0.4, which I believe, I did check this, but it's 3/8, which is that. And so P is 0.375 minus 0.25. So often the method being what it is, just be careful not to slip up at the end. So it's 125, which is actually an 8th. Okay. So P we have found. We've got P is 0.125, is 8th. How do we find the other two? Well, that's nice that we've already got one from that piece of information. We've got the probability of C is 0.3. That's our next piece of information. So P of C equals 0.3. That piece of information gives us something else. So if we look at probability of C, it's going to be P plus Q is 0.3, and we've already got P, so this one's worked out in order. We're not having to do sort of simultaneous thing. So Q must be equal to 0.3 minus P, which is there. Okay, and again, I find it it's quite common for this sort of question and things like vectors for you to skip ahead a bit too fast and get the numbers wrong. So take your time to make sure they're right. I make that 0.175. I haven't checked these. That is what I'm getting. So finally R. Now we haven't been given any third piece of information, so we have to think about how we find R. And the one fact that we know with probability is going to be useful, this is going to come up in the next Friday's lesson, tomorrow's lesson, is that if we sometimes see this sort of curly E here, and this is our sample space, this is our set of people that we've asked, or it's the total population that we're asking. So that is everyone in our group. So this is going to be, if we add up all of the probabilities in this group, we must get to 1. So all the probabilities, there's no one escaping outside, must equal to 1. So if I add up all of these, I should get 1. So if I do that with a whole list, I get 0.25 plus 0.15 plus 0.1 plus P plus Q plus R, all add up to 1. And from there, I can, got P plus Q is 0.3, so I can start to add these together. This is 0.4, 0.5. These two added together are 0.3. I'm just going to steal that blatantly from there. Plus R equals 1. And if I rearrange that, I'm going to get 0.8 plus R equals 1. And I make that R equals 0.2. So what you can do if you want to double check those is you can put all of these back in. And yeah, I've got R equals 0.2 out of that. So that's all for question 1. They might come up in different orders. Again, you might have questions there where you need to draw a Venn diagram. If it doesn't give you a diagram, I really recommend going for it. Sometimes you can work things out without a diagram, but I find it so useful to be able to organise things into areas and hence work out the problems. So have a go. Remember, when you're drawing them, it's going to be easier to work from the inside, from the intersections outwards. But have a go, good luck with those, and see how you get on. Hopefully it's sort of familiar from before. Take care, all the best, bye.